Worland, talking about long-term prairie monitoring projects involving birds and a connection to a new project involving Prairie Plan Evaluation briefly. So I know Daren's going to talk a lot about veg too. So it's going to be great. So take it away, guys.
Okay. Good afternoon, everyone. Can you hear me okay, Jess? Sound check?
I can. Yep.
Okay. And assume you can see the presentation on the screen?
Yep.
Okay. So good afternoon, thank you, and happy winter solstice to everybody. I was going to make some comment that we can all look forward to getting some extra daylight tomorrow, and then I decided to check, and actually we don't gain a minute until Monday. So, you know, even if you've been naughty this year, you're still going to get a minute present for Christmas, I guess. So yeah, as Jess mentioned, this is the bulk of what Mike and I are going to be talking about is a long-term prairie monitoring project that was started up in 2008, looking at both vegetation and birds. I'm going to give a bit of an overview about the project structure and then results from the vegetation, and then I will turn it over to Mike, who will talk about the bird results as well as a new endeavor that he's been sort of taking the lead on with additional bird monitoring. So, I got to make sure I can advance my slide here. There we go. Just real quickly, kind of some background. As I said, this was actually 2007, 2008. This came out of the Wildlife Action Plan, the original 2005 Minnesota State Wildlife Action Plan, recognizing that tallgrass prairie, the loss of tallgrass prairie rivals that of basically any ecosystem in the world. In that original plan, we identified more species in greatest conservation need in prairie than any other habitat. The 2015 Wildlife Action Plan revision identifies prairie still as a priority. In addition to native prairie, what was termed in the original 2005 SWAP surrogate grasslands or non-native prairie are also declining, primarily loss of CRP, but other reasons as well. And especially at the time, there was limited prairie monitoring in Minnesota, as well as questions about management. Grazing was really just kind of beginning, and I'll allude to that. I'm not going to talk too much about management here. Mike has a little bit, I think, but I'll allude to some other efforts that this ties into. So the status trend monitoring, the approach that we took was to focus on high-quality native prairie plant communities. Main question was how are plant and bird communities changing over time and in response to key drivers of change. And after several work groups back in 2007, I think it was, we identified the two main drivers of change, climate change and landscape context as potentially affecting prairie. How do you measure climate change? Our best approach was to stratify by geography to see if we can see and then maybe throw in climate variables as needed and warranted. Landscape context, we stratified by sites that are large sites embedded within a grassland matrix versus small isolated sites. And I'll just give a little example of that. This is the geographic strata. There's 5 different zones, we call them, ranging from the aspen parklands in the northwest to the prairie coteau in the southwest. These were really kind of a precursor to the Prairie Plan cores. Identify where are those concentrations of prairie across the state, draw some boxes around it, and group sites within there. We do have, couldn't exclude this one that's like the only prairie in the actual glacial lake bed, so Malmberg Prairie is included, but largely they're within these 5 zones. Landscape context, we stratified the sites by size and the surrounding buffer around a site. So there's what we're calling the small isolated sites here. SI, small and isolated, so they're less than 50 acres, actually generally less than 25 acres, with less than 50% grassland or really open habitat within a 500-meter buffer. Large embedded sites are larger than 50 acres with more than 50% grassland in a 500-meter buffer. And this is an example. These are both sites. This is Langhigh Prairie. This is Ordway Prairie. That would be in Zone 3, the middle zone. This is the same scale, so this is a really small prairie. I forget, it's maybe about 30 acres in size, as opposed to Ordway Prairie, and surrounded mainly by row crop agriculture, as opposed to Ordway Prairie, which is several hundred acres in size with a lot of grass in the surrounding matrix. So the overall sampling summary, we have 5 geographic zones, 4 replicates of sites, each of large embedded and small isolated sites in each zone, so 8 per zone, 8 sites per zone, 40 sites total. This just gives a list of the sites. Here's the 5 zones. Small isolated sites, 4 in each zone. Large embedded sites, 4 in each zone, summing up to a total of 40 sites. I'll say up front, we did do a power analysis, and as you some of you might go, oh, that's not a lot, and it's not. We're on the very edge of being able to make trend results with the number of sites, but we even at this limited number of sites, it's a challenge to maintain a long-term monitoring project with the funds that we're able to procure. Love to see more, I guess is the message there. Sampling is done through a split panel, or the sampling by year is done through a split panel design. As I said, we actually started this in 2008 and 2009 as pilot years just to do the power analysis. Most of the sites, we have dropped some and added some since then, but I think about 35 of the sites were sampled in those first 2 years. And then after that, we began this split panel design. Originally, it was going to be 12 per year, then we dropped it down to 10 per year. So in any given year, there's 4 sites that get monitored every single year. And just to get some sense, we can't really get much of a statistical analysis, but some sense of the annual variation that may be occurring. The remaining 36 out of those 40 sites are sampled every 6 years, so there's 6 sites in any given year. And we've been a little fluctuation trying to get things on schedule, but going forward now we're going to be having 10 sites sampled every year. And we have gone through 1 complete rotation, so all sites have been sampled through this complete rotation, so that's why we're able to do some initial results. And just to quickly show how the sites array in relation to the Prairie Plan, cores and corridors. As I said, this was really kind of used the same information, identifying where those concentrations of prairie are. So there's a lot of overlap. Not entirely. There are sites that fall outside of cores and corridors. Just kind of a little bit of food of thought, how this might maybe be useful for Prairie Plan evaluations in the future, maybe modifications. Totally open to ideas on that. I also want to give a call out to the grassland monitoring team, because as we started this, one of the things we want to make sure is that this had value in terms of management questions. So Sarah Vosick from the Fish and Wildlife Service gave a presentation on the grassland monitoring team on this series back in October, I believe. So I'm not going to go into too much detail about that, other than to say that we're utilizing the protocols. The data that comes from this is also fed into the adaptive management model. So there's kind of 2 dual values of this information. One is the status trend, as well as then adaptive management. But real quickly, the monitoring protocols that we adopted from the grassland monitoring team, there are 3 levels. In effect, there's really only 2 that are being used right now. The basic option A, which is kind of the quick and dirty version, versus the deluxe version, sometimes call it the Yugo versus Cadillac. Deluxe version, where all the same core data is collected as what's collected in the option A, but then you add on more detailed species level information. For this project, we're collecting all at the option C, the more detailed version. But quickly, the vegetation monitoring is done by 25-meter long transects with 50 or half-meter long quadrats along that. So there's 50 half-meter quadrats along that 25-meter transect. In addition, there's a broader transect to pick up additional indicator species, just presence, absence. And the quadrats are only 10 centimeters wide, very narrow, and half a meter long. But this allows for at least frequency analyses, which is quite valuable for looking at trends. Bird monitoring protocol that Mike will be talking about the results more, but just a quick overview of how that is done. 10-minute point counts, pretty standard 10-minute point counts, recording all bird species in 4 different distance categories. I know this kind of looks like a screen capture from a drone shot, but this is actual site, Santee Prairie up in northwestern Minnesota, actual point, and here's the concentric distances. They're estimated. We do some calibration at the beginning of the year using a rangefinder, but then estimate the distances. Also record sex of the species of the bird if possible, and breeding evidence, but I would say, I don't know, 90% is pretty much recording singing males. These are recorded on data recorders where we have a timestamp, so we're able to do some additional detectability analyses with that information. And then stepping into some results, first just to remind you of the zones. So Zone 1 is the northernmost in the Aspen Parklands. Zone 5 is the southernmost. And we ran generalized linear mixed models, including zone, year, site as a fixed effect, and then landscape context, as well as observer. And it turned out when we looked at native species richness, this is the number of species per transect, of native plant species per transect, the model that was significant and the best fit had zone and year, zone and observer and year came out in the model. Zone, geographic zone was high, and observer was highly significant. And there was actually one observer in particular who was found a lot more species than other observers we've had over the years. So just a kind of a cautionary tale about making sure to include an observer in the analyses. Year was marginally significant. It was right on the edge. But basically, the overall summary here, these are, try to get my pointer, these are the zones, northernmost 1, 2, 3, 4, southernmost 5. Zones 1 and 2 had significantly higher species richness per transect than zones 3, 4, or 5. Overall, though, there was a increasing trend across all the zones, an increasing trend in species richness per transect over the 6 years that we've been doing this. Landscape context was not significant in the model, although when looking at the data, we do see that maybe the trend is, there might be indications, it wasn't significant, but there might be indications that large embedded sites had a steeper trend. This is something we'll have an opportunity to examine in the next iteration of the next 6-year cycle. Another way of looking at this is using some of the core data from the option A of the protocols. Within the option A, one of the things that is done is to record if a quadrat is how much native versus non-native cover is in that quadrat. So that's in 4 different categories. One of the categories is it more than 75% native plant cover. When looking at this, threw into the same model, same variables of zone, landscape context, observer, and year, as well then site as a fixed effect. It turned out that the best model fit was geographic zone again and monitoring year. Zone was highly significant, and we'll see that zones 1 and 2, that again the 2 northernmost zones, almost 100%, almost all of the plots were dominated by native plant cover, and that drops considerably in the southern zones once you get into the central zone 3 down to zone 5. Year was actually, there were some trends, but year was not significant. It was the zone, these 2 zones 1 and 2 being just so distinctly different from 3, 4, and 5. And this is just another way of kind of looking at this, looking at the indicators. There's 5 different groups of indicator species. There's a tier 1 of invasives and a tier 2 of invasives, tier 1 of native, tier 2 of native, and then a disturbance indicator group. Just want to focus on the reds, just showing how these are the tier 1 invasives. It's 25 species, the most prominent invasive species that we have on the prairies. And you'll see going from geographic zone 1, the mean cover per plot increases as you go south, pretty much, with some fluctuation in between. Patterns of the others, I'm not sure you can make a distinction, but just in the interest of time, focusing on the red, showing that yes, indeed, the Tier 1 invasive indicator species are increasing, have a much higher presence of cover in the southern zones than the northern zones. You can also, with the deluxe version of the protocols, look at individual plant species. This is just looking at smooth brome. Bromus inermis, again, did the same model, looking at all the variables. And what came out significant with this was that we couldn't get the model to converge, because basically in zones 1 and 2, smooth brome is non-existent. The frequency of smooth brome was essentially 0. So we reran the model with using just zones 3, 4, and 5, and we found that there was both a zone effect and a zone by year interaction effect. So basically, zone 5 had a marginally increasing cover or frequency of brome over time. Zone 3 had a significantly decreasing frequency of brome over time. So I believe with that, that's just sort of, there's many other examples of ways we've analyzed this data. Just kind of want to get a snapshot of some of the things we've done so far and what we can present. So I'll pass the ball on to Mike. And I have to do it, I think. Mike, right?
Yep.
Participants. There we go.
Okay, you guys seeing my screen okay? Hello, can you guys hear me?
Getting there, it's going.
Did you see Allison's cat?
Yes.
Allison's cat. There you go.
Okay, do you got that? You got that slide filling the screen okay?
Perfect, Mike.
Good. So I'm going to talk about the prairie bird component of the project. And if folks are familiar with grassland birds, they know that any project focused on them is going to be filled with bad news, and this project is no exception. One point to get across before we get started with the data, you know, there's lots of bad news here, but I think it's important for us to communicate that and get across to people that these results, you know, they're showing us what's coming down the pike for these birds. I think there's real potential for these birds to achieve even federally endangered status, and so it's in everybody's best interest to avoid that situation and work to stop that from happening. I'm kind of giving a conclusion here at the beginning just to set the context, but I want people armed with information before they see these trends, so we know, you know, just so you know how to interpret them and you're thinking about them in context, thinking about positive things that we can do with this information. So this kind of tells the story of grassland birds focused on one species. This is the western meadowlark. The trend you see on the left there is a breeding bird survey trend that I'll talk more about. But you can see their population has really plummeted over the last 40 or 50 years. You can see in the recent trend looks like it has kind of flattened out. The data I will show that it has not flattened out. It's just that the numbers have gotten so low that you can't see the trend in this graph. But basically, the proportional trend here at the end basically matches what was happening earlier. It's just the numbers have gotten much lower. A couple of key points to make here about breeding bird survey data versus what we're doing with prairie monitoring. Number one, breeding bird surveys are roadside surveys. So they're 25-mile long routes that occur exclusively on roads. But our project occurs throughout the entire prairie, and so we're in the interior as well as the edge and cover the entire prairie. So there's probably a bias with roadside surveys. In fact, we know for some species there is a bias. One hopes that that bias remains consistent throughout this entire trend, but there's reasons to suspect that may not be the case for some species. But we don't have that bias with our data. Another important difference is that breeding bird survey data occurs across the entire landscape, regardless of whether there's good western meadowlark habitat there. So part of what you're seeing reflected in this trend is direct habitat loss. So habitat being converted into agriculture very often, or urban sprawl. We are focusing exclusively on protected remnant prairie. And so direct habitat loss is not causing, is not a factor for us. There may be other habitat loss in the surrounding landscape that is a factor, but not the actual place where the birds are living. One would hope that these sites, these remnant prairies that are protected, would serve as kind of a reserve for these birds, that these are the places where these birds can hang on. And I'm going to show that that is not the case. We cannot rely on these places as of now for these as reserves for these birds. Just a quick look at our overall data. There are 26 grassland specialists. One thing that jumps out from this slide is that 3/4 of those grassland specialists are species of greatest conservation need. That's a designation given by the Minnesota Wildlife Action Plan. For species that are having troubles of some kind or another, most of them are showing declining populations. So 3/4 of grassland birds are in some sort of trouble. The red bars show species that have numbers that are adequate, that allow us to model them. And those are the species I'm going to focus on today. Certainly the other species are very important, often because they are rare and uncommon. But there's a story we can tell with the abundant species that gets across the point that they're declining and in trouble, and we can do that with some rigorous models. So we'll jump right into the data. The bobolink, of those 8 species that I'm focusing on, the bobolink is the only one that does not show some sort of a significant decreasing trend. The bobolink is just barely not significant. By significant, I mean for the 95% confidence interval, it overlaps 0. So that means there's a small chance that that trend is basically flat and not declining. Just to give a little bit more information into what these trends mean, since we're going to be spending a little bit of time on them. The points that you see there are affected by site bias. So because of that split panel design that Daren was talking about, different sites are surveyed each year, and so different sites are reflected in these points. So for example, in 2017, last year, maybe that was low because we had a bunch of crappy sites for bobolinks. In 2012, maybe that was glorious habitat for bobolinks. So the points are affected by that bias. The points are not affected by detectability bias. So for example, in 2017, I did a lot of those surveys. In 2012, I'm not sure when Bob Dunlap was surveying, but if he was surveying that year, you might say, okay, that's the Bob Dunlap effect. This is the Mike Worland effect. But these points are, we modeled these points and accounted for detectability. So that bias has been removed from with the pattern that you're seeing here. And that's a site bias, that is potential. But the main point I want to get across is that the red trend line you're seeing accounts for that site bias. These are linear mixed models, and it basically removes any bias due to different sites being surveyed each year. So some details maybe you didn't necessarily need to hear, but it's, you know, trends trends are often communicated as being very simple, and I think it's deceptive. Trends can be pretty complicated what goes into them. And it's important to know, it's important to have some understanding of what's going on when somebody says they have a trend. Clay-colored sparrow is the next species. It has a marginally significant decline. You can see from the coefficients up here, it almost overlaps 0. It just barely doesn't. In 2008, we were getting, the model tells us we were at 5 birds per 10 hectares. In 2017, it's close to 4 birds per 10 hectares. So that's the lowest decline of the species that have declines. Savanna sparrow, you can see that in 2017 we had a very low density. That's largely driving the trend you're seeing here. I don't think in 2016 this had a significant decline. But right now with the 2017 number there, Savanna sparrow is declining by about 5% per year. And we'll see if that trend continues in the future, or if 2017 was just an aberrant year for some reason. Western meadowlark. So again, this was the species for which I had that breeding bird survey trend earlier. And it looked like it had kind of flattened out recently. It shows it has not flattened out recently. It is declining by about 5% per year. You can see that in 2008 it had close to 1 bird per point count. In 2017 it's close to 0.5 birds per point count. So that's about a 5% per year decline. The graph makes it look like it's been cut by about 50% over the last 10 years. If you run the numbers, it's actually closer to a third. It's been cut down to about 67% of its original population at the start of the study. So when I saw that, I was like, woohoo, it's only been cut by a third, not by a half. And I'm being sarcastic there. It was not very good news, really. Sedge wren has been cut by about 6% per year since we started the study. Its population down from nearly 4 birds per 10 hectares to about 2 birds per 10 hectares. Grasshopper sparrow, its population declining by over 7% per year. And now we are getting to the point where their population has been cut in half in a 10-year period. Upland sandpiper, also over 7% decline per year. Its population cut by more than half in the last 10 years. Also, ring-necked pheasants on these remnant prairies, their populations are declining by 7% per year, despite a pretty high number back in 2017. Otherwise, the population decline probably would have been even steeper. But as of now, it's about 7% per year. So Daren's design of this study allows us to isolate the effect of landscape context on these birds. And so we can look at the effect of landscape context, and in doing so we find that the species with the steepest declines are showing the strongest affinity for large embedded sites. Western meadowlark, grasshopper sparrow, and upland sandpiper used large embedded sites a lot more than the small isolated sites. There are 2 important exceptions to this. One is sedge wrens, who are showing a pretty steep population decline. They are using large embedded and small isolated sites about the same, as are ring-necked pheasants, the rightmost graph here. So they were declining, but they don't seem to be affected by landscape context too much. So something else is going on for those birds besides landscape context. The 3 species that were declining the least, clay-colored sparrow, savanna sparrow, and bobolink, did not show any difference between large embedded and small isolated sites. So landscape context is important and definitely a major driver of these trends we're seeing, but probably not the only thing that's going on. So thinking about landscape context, we know it's important. What is the grass actually doing in the state? What kind of patterns are we seeing? Dustin, what is Dustin's last name? Graham, thank you. Dustin Graham with Minnesota Biological Survey did this analysis on remnant prairie. We all know that remnant prairie, that there's less than 2% of the original remnant prairie remaining in the state. And about half of that is protected, but the other half that is not protected is not necessarily safe. About 250 acres per year of remnant prairie is being altered or destroyed. But probably the biggest thing going on is overall across all grass habitat. I don't have data showing what is happening to all the grass habitat in the state, but we know from CRP we have a pretty good idea of what's happening to it. CRP is a major driver of what's going on with grassland birds. In 2011, about half of the 3 million acres of grassland in the state were in CRP, and this graph shows you what's happening to CRP in the state. It's plummeting. CRP, by the way, is Conservation Reserve Program, where farmers are paid to keep land that is otherwise suitable for row crops, keep that land in grass. And so those numbers are plummeting, declined by 0.7 million acres in Minnesota in the last 10 years. And so that's part of what's going on with grass, and probably a big part of the problem for these grassland birds. So a lot of gloomy, somewhat depressing news. But one thing I want to get across is that we really need to use that as a driver to affect change. And there is change going on. There's a lot of work being done under the Prairie Conservation Plan by folks. 3 different kinds of conservation activities fall under this plan. There's protection, restoration, and enhancement. We know that thousands of acres have fallen under one of these 3 activities over the past several years. Lots of money have been spent on this, millions of dollars. There's been some challenges recently with funding, but we know that there's some optimism for some more funds and some more energy coming down the road. One reason for that is the Minnesota Wildlife Action Plan that I'm helping implement down here in the southern part of the state. So there's reasons to be hopeful that we're going to be able to conserve some more prairie and get some more grass on the landscape. But part of our question is that doing any good? Is that really affecting these wildlife populations and other benefits that come from prairie? When you look at things like this, major drivers of what's going on with grassland birds, it's a legitimate question to ask, how can we move the needle on these birds when big things like that are going on? So towards that end, we are implementing a pilot project to monitor effectiveness of the Prairie Plan. We've got a grant, a federal migratory bird grant to implement this pilot. The project is starting now. We're just now in the early phases of planning it. So I really can't say a lot about it or go into a lot of details about it because we don't know, but it's going to start, the data collection for it will start this summer. And we're now in the early phases of planning it. People on the project are myself and Daren, Marissa Allering from TNC, Kristen Hall from Minnesota Audubon is on it, Ben Walker, and the names are going to be challenging for me here off the top of my head. Ben Walker, Kelly Van Beek from Fish and Wildlife Service, Jessica Peterson from DNR as well. So this is the team we've got going. We've got a statistician hired, or that we're going to be hiring to work with us on the project as well. We're going to be focusing in the southwest part of the state for the purpose of this pilot, but the long-term monitoring project that we hope this pilot will lead to will cover the entire prairie region of the state. The real challenge here is going to be isolating the effects of these prairie plant activities. So we're not just looking for grassland bird trends. The Breeding Bird Survey does that. The Prairie Monitoring Project that we just presented does that. We want to isolate the effects of prairie restoration, and things like prescribed burns and other prairie management activities. Again, you can see from what Daren showed, prairie monitoring sites largely overlap the Prairie Plan network, and so our hope, we believe that this prairie monitoring project can be a big part of evaluating Prairie Plan effectiveness. So I'll just summarize some take-home points of the stuff that both Daren and I presented. First, when you're talking about prairie quality, landscape context, geographic context is crucial. Northern zones tend to have higher native species richness and less invasive cover than southern zones. Also, vegetation quality does not vary by landscape context. So this could be, to some extent, good news for managers. It shows that managers have, relatively speaking, some control over the vegetation on their properties, and that they can improve that vegetation quality despite the surrounding landscape sometimes. Also, detecting changes in prairie vegetation requires long-term measurements because of the persistence of the prairie plant community. For birds, grassland birds are disappearing from even prairie that is intact and protected at alarming rates. And by alarming rates, I mean populations are being cut in half in a time period as small as 10 years. That's happening now. We are losing grassland. We are using grass at the landscape scale, and that is a major driver of what's happening to these grassland birds. We are looking rather desperately for a positive story that we can tell about these grassland birds and other components of grass. And so that's part of what we're doing with this Prairie Plan evaluation, is we're looking for a good story to tell about grassland birds and how they're responding to our management. So that's all I've got.
Thanks, Mike and Daren. I'm happy to open it up to questions now. I'm sure there are several, as we have a large audience today. So if anybody wants to ask a question for Daren or Mike, you can just type it into the chat box, and we'll try to get your questions answered. Come on, I know you guys have questions. Okay, let's see. Oh, that's long. Who's that? Oh, that's Nicole. So Nicole says, in talking to another grassland bird researcher several years ago, I was told that sedge wrens have very low site fidelity, even for a grassland bird, and lead rather nomadic lives, sometimes starting their breeding season farther north and then moving south as the season progresses. My own survey experience also tells me that they can be abundant in some sites one year and gone the next. I also had sites where marsh wrens showed up and the sedge wrens disappeared. What are your thoughts on this? Do you see any such pattern in your data, i.e. more abundant to the north early in the season, showing up later in the south? And what do you think this means for detecting their trends and figuring out where they lie in terms of grassland bird conservation priorities?
Okay.
That's a lot.
Yeah, I can't say much about the north-south thing that you just said. The low site fidelity makes a lot of sense, though, and I think we have some indications of that in our data. I didn't talk about response to burning because of time, but one thing we saw, sedge wren had one of the stronger responses to burning. In sites, the year a site was burned, sedge wrens were basically non-existent. And that low site fidelity makes sense there, because some birds that have site fidelity are going to be breeding in a site even if it's questionable or marginal quality for them. But as soon as the sedge wrens come back and they see the site has been burned, they take off. And so that we're seeing that, and that's possibly a driver of what's happening with sedge wrens, because they respond so drastically to burns. You know, if a site is being burned, say, once every 4 years, that means 25% of the time that site is basically completely unsuitable for sedge wrens. So I think we're confirming part of what she said there, yes.
Mm-hmm.
Yeah, can you hear me?
Yep.
Yeah, we can hear you.
On that, I mean, I think sedge wren was one of the sharper declines that you had, Mike, is that right?
Yeah.
And so, you know, one of the things when I saw these results that Mike had done and thinking about, okay, these are intact prairies, the vegetation, I mean, the plant communities are still looking pretty good, if not improving. Yet we're still seeing these dramatic declines. And so there seems like there's a larger regional population level issue going on with many of these species. They're not just, and it would make sense, particularly those that have low site fidelity, you know, if they're going into, maybe the sites that we've chosen are source populations, maybe they're not, I don't know, but they're generally at least the, you know, good quality sites. But if they're overall, the regional populations are being impacted, that would kind of lead to that, you know, the site fidelity could impact that, the larger regional population as opposed to site level effects.
Okay. Jeff Sajak has a question about, was there any variation of bird numbers or species when evaluated against native versus invasive plant cover? So kind of merging the two data sets.
I have not analyzed bird response to that. I mean, part of the problem is that, you know, the study, the monitoring project really wasn't set up for that kind of objective, where, you know, we're surveying for birds in a 100 meter radius, and we're sampling plants in a 25 meter long, 10 centimeter wide transect. And so it's tough to make a match between the vegetation and the birds at that scale. Anyway, at this point, I don't have a good answer for how birds are responding to native versus invasive veg. The literature tells us that the response probably is, it's not as crucial for birds as it is for other things. Some birds can do quite well in places that are dominated by invasive plants, but our data can't give us any more details than that.
Okay. Robert's wondering about the veg data as management being looked at, notably grazing.
Yes, and is part of a broader analysis using the grassland monitoring team data, so it's a larger data set, and several of us have been working on that, working on a publication actually, and the signals aren't real strong thus far, and it probably leads a little bit to this. It takes time to see changes in plant communities, although we are seeing, I don't have the details in front of me right now, but we have seen some indications that there's differences between grazing versus burning as part of the grassland monitoring team results. However, it's mixed in how you look at it. So we're still looking for that story to tell from that, but there's it's, as I said, it's not real strong right now.
Yeah, and as Daren alluded to, Sarah gave a broader grassland monitoring team talk on November 2nd, and this just is a reminder to me to tell all of you, if you Google Little Lunch on the Prairie YouTube, it should take you to the YouTube channel where you can find all of those, and that was on November 2nd. So let's see. Fred had a question about, is there any evidence that the dramatic loss of insects over the past couple of decades could be contributing to grassland bird population decline?
I'd say there's evidence. I mean, I don't think we have it in this project, but that's probably it deserves more study. That's the simple answer. There's it's likely a factor. I'm not sure how it couldn't be a factor. And yeah, when you look at some of these birds that are declining, despite the fact that their habitat is protected, there's got to be some explanations, and insect abundance is very likely a pretty big driver. But yeah, that requires a more focused research project than what we've got here.
And I think people are doing that.
Are they? Yeah.
Yeah, there's some research out of Canada, I think, looking at birds and insects, and specifically insecticides. And I know Mary Beth has sent several notices of that in the LTT, but I can dig up some more too if people are interested. Looks like Robert was maybe having telepathy with Fred. They're so close to each other physically right now, so he basically asked the same question. Jeff Zajac wanted to know if there's any tracking of cowbird use or abundance on these sites.
Yeah, we track cowbirds, pretty low numbers. Yeah, I don't have the data handy, I guess, but we did track cowbirds, and that is a good point. It's something to look more closely at, is how, since they are such important nest sites. But at this point, I've done no analysis on cowbirds.
Looks like, at least right now, we have one last question. Are the population trends you found in agreement with other bird survey trends within the state?
I think they're a little bit close. For example, sedge wren, last time I checked, I guess I can't say right now, they were not showing the kind of steep decline statewide that we're seeing in this project. Some of the other species are showing some of the steepest declines in the state across all birds. You know, the meadowlarks, the upland sandpipers, they're showing, I think, somewhere in the 5 to 10% area statewide, and so our numbers are pretty comparable to them. Yeah, I mean, and again, that BBS, the breeding bird survey trends, are taking all habitat loss into account, whereas our sites are protected. But yeah, they are similar. If you go to the breeding bird survey website, you can see those trends, and it's depressing.
Okay, on that cheery note, thanks so much, Mike and Daren, for getting us up to date on this wonderful project and giving us a little teaser about what's to come with the grassland bird pilot project. Thanks to everybody that's joined us over the weeks. I think it's been a lot of fun. I've certainly learned a lot and heard from a lot of people that they have as well. So please, again, I put my email in the chat. Oh, we've had a resurgence of a couple other questions. Can you talk about reasons for higher native plant species diversity in the northern zones from Hannah? I was kind of curious about that too. Daren, are you still there?
Yeah, I am. And I think at least three things come to mind. One is that as much as we try to select similar prairie types across these zones, the reality is there's only so much to choose from, and the landscapes are different. I would say that there tends to be, it trends more towards the dry prairie as you get further south, particularly in zone 5 for sure, zone 3 maybe not. So I think there's a bit of that, so difference in prairie type, but we try to keep it centered around mesic prairie. There are some examples of wet prairie with even wet meadow inclusions, and dry prairie as well. But I think there's a little bit of that. So part of it is just geographic, just the difference in the landscapes. We've looked at, you see that there's a lot higher invasive species presence in the southern zones. And we've looked at that. There's a really strong, just from some of the simple measures that are done in the basic protocols, there's a strong relationship between that invasive species presence and species diversity. So I think that the invasive species are really impacting the diversity of native plant species. And I also think that, especially as you get up into the northernmost zone, even though landscape context did not show up as being significant, I still have a hard time believing that it's not. And in the Aspen Parklands in particular, it was really hard to find small isolated sites. And some of them are kind of stretching. They're on that borderline of the two different, the two strata that we have. So I think just in general, the sites, particularly up in Aspen Parklands, not so much on the glacial beach ridges, but maybe so. So I think there's a little bit of that landscape context effect. But the data doesn't back me up, so I don't know what else to say about that.
Okay, one last question. Are killdeer and horned larks showing stable or increasing trends?
The killdeer and horned larks didn't have enough numbers for us to run these models for, but they are among the species that I looked at kind of their presence absence in sites over time. And actually, killdeer seem to be doing pretty good as far as their presence at sites. A lot of those species are kind of starting to disappear. Marbled godwit is one. Prairie chickens. We're not finding them at sites where we used to find them. But killdeers were an exception to that. They seem to be maintaining their presence pretty good. And I think horned larks are the same way. And those are two species that are associated with very sparse vegetation. And I don't know if that's part of the reason they're doing okay or not. But anyway, overall, we don't have any evidence that their populations are declining by very much.
Mm-hmm.
Yeah, and it's pretty rare that we'd even find those within the prairie, unless it had just been burned that spring. They're more on the periphery and utilizing the ag fields.
Okay, well, thanks to our presenters and thanks to all that have tuned in. Again, please email me with comments and future ideas for future webinars if you have them. So it's been fun. Thank you all so much for your participation.
Thank you.
Thank you.